Hello everyone, today's video will show you how to design a servo controller and use the PMOD port on the Basys 3 board to control the servo. However, most servos require a 5V power supply and the Basys 3 board only provides 3.3V outputs. This means we need an extra component to provide a 5V power source. Here I am using a simple power supply module. It can be powered by USB and provides a 5V or 3.3V power supply. We also need to switch to the external power supply mode on our Basys 3 board. As you can see here, we need to set jumper JP2 to EXT. The servo I choose is called the MG996R. It has 3 pins, one for 5V power, one for ground, and one for the control signal. Here's the block diagram and connection for today's project. As you can see, we use an external power supply to provide 5V power to the Basys 3 and the servo. Then we use our computer to generate the desired input degree for the microblast. Next, we will design a servo controller to generate a PWM signal to control the servo. Please note that the USB power source requires a current greater than 2 amps. Otherwise, it cannot provide sufficient current to drive the servo. Here's the actual connection for today's project. Let's quickly create a new project. Add a clock riser. Add the microblast. Add the UART port. Next, we need to create a new IP for controlling our servo. Let's create an XI peripheral. We will call it servo control wrap. Let's edit it. First of all, at the bottom of the XI wrapper, we will add our servo controller here. You can copy the code from my website. Let's take a look at the code. I won't go through every detail here. I've added comments to help you understand it better. First, this module has a 10 MHz clock input, a reset signal, and a degree value indicating the angle the servo will turn to. Then there is a PWM output. Here we define the stop point, which determines when the PWM signal should go low. We count different ways to achieve the desired angle. I have 7 angles to choose from, range from 0 to 180 degrees. Then we have a counter to generate a 50 Hz cycle for the PWM signal. Lastly, we have a state machine that determines when the PWM signal should be high and when it should be low. Next, we connect the reset signal and use register 0 to store our degree information. We also have 2 custom I/O, one for a 10 MHz clock input and one for the PWM output. For these 2 custom I/O, we need to add them to the interfaces. Here, here, and also here. Then we merge all the changes of our IP. Click Repackage IP. Now we can add our new IP here. Connect the wires. Right-click on our PWM output and select Make External. Change its name. Double-click on the clock wizard and select Output Clocks. Let's create a second clock with a 10 MHz frequency. Then connect our 10 MHz clock to our IP. For our custom PWM output, we need to add a constraint. Let's add a constraint file. Create a new one. Copy the content from my website. As you can see, I assign a PWM output to one of the PMOD ports. I use JB9 here. Let's create a HDL wrapper. Then we can generate a bitstream. After generating the bitstream, export the hardware. Launch the Vitis IDE. Let's quickly create a platform and then create an application. You can copy the C code from my website. Let's take a look at the code. Here, I detect the computer's input and send it to the microblast. Only 1 to 7 are valid inputs. Then you can connect your Basys 3 board and run the application. As you can see, my servo successfully turns to the different angles according to the input degrees.